You're tuned to the IP Communications and VoIP community in our 11th year. To produce these weekly meetings, we really appreciate the support of Simwood.com. Simwood can turn you as a developer into a telco. Our longtime friends at Greenfield Tech can make your tech dreams feasible and affordable. Go to greenfield.tech. For 8 years, we've been using the finest conference server around, ZipDX.com. The VUC website is on bluehost.com. Our local rate dial-ins from around the world are from voxbone.com. All right, thank you, Michael. And if that isn't a .com rebound, I don't know what is. And today we have our esteemed guest who hasn't been with us for, I think we figured 6 years. It's Brough Turner from netBlazr. Brough, welcome.
Thank you. Happy to be here.
We're really pleased to have you. I just would like to take the time to introduce everybody in the film strip besides Brough, and everybody's going to have a chance to say hello, starting with Mr. Andy Smith.
Hello.
Good. Nicely done. The next person is in Scotland. His name is Corrado.
Hello, everyone. Good evening.
Now
good morning, depending on where you are.
Right. We have the impeccable James Bodie with his tie.
Good evening, ladies and gentlemen.
Mr. Michael Graves is with us.
Hello from Texas.
And he's the American, he's the only American correspondent because Tim Panton is in a car. We have no video for him yet. Can you click that video?
Hi, it's Tim. Oh, wrong camera. There, you get my car anyway.
There he goes. Look at this, Mr. Tim Panton. And he is not driving. Safety geeks, he's not driving. And this is me, Randy. And I'm really, really thrilled that we were able to do this. This is our 11th year. We've been doing this for 10 years. And about 6 years ago, this fellow, Brough Turner, who is a rebel like I am, decided to do what he wanted to do. And I'm going to call on Brough to tell us, first of all, remind us what netBlazr is about and what they're doing, and the evolution, because apparently there was a turn of events a few years after they started. So let's hear about the history of that, Brough.
Okay, well, your illusion that the origins of things, basically I was pissed off about broadband in the United States. In the early 2000s, I was engaged in what was then Natural Microsystems and later NMS Communications. But in 2008, I was no longer in control of things, and the company was split up and sold off, and I was at loose ends. So I sat around, did some consulting, and thought about things. And really what I wanted to do was to find a way to do an end run around the broadband monopoly in the US. And I'm perceived as being a wireless expert, which may or may not have been true at the time. But at least I gave talks on wireless related things and 3G and 4G wireless. So I concocted a plan and I recruited a couple of partners, and we started off in 2010 in Boston, looking to use a combination of a limited amount of fiber and a lot of high-speed point-to-point wireless links to deliver broadband internet access, high-speed internet access to people in the greater Boston area. Well, of course, you do a startup and you're naive about a bunch of things. And in my case, I had enormous amount of theoretical knowledge of wireless, but not so much practical experience. So we struggled with technology in 2010 and early 2011, and then we struggled with business plan in 2011 and 2012. But in late 2012, we finally broke the code on something that made sense. We're still scrambling to develop our infrastructure, but we do have a business that is EBITDA positive, and basically we're still investing capital but it's throwing off cash, and probably by early 2018, it will be throwing off cash, including all the capital investments we're making, i.e. it will be very profitable. And we're growing rapidly. On the other hand, we're not about to challenge Comcast yet or change the way things happen in the US, and that is my long-term goal. So at the moment we have a little over 2,000 subscribers. We're in hundreds of buildings in the Boston area. We have, for residential users in apartment buildings and condos, we are constantly installing new buildings. So one of the metrics is how many doors do we pass? And the answer is around 10,000 at the moment, because those are potential people to sign up for our service. So it's not hard to compete with Comcast for service in urban areas. And I can talk about the technology and or the business plan.
We should actually start with what you're doing differently from others, because I think that's quite a difference.
So there are people using fixed wireless technology to deliver internet access services. There are, in fact, thousands of small companies doing that across the US and throughout the rest of the world, but the majority of them are in rural areas, and the majority are using 5 gigahertz unlicensed spectrum, and things work fine because in a rural area there's relatively little interference. There are relatively few people doing what we're doing. 5 or 6 other companies in other specific markets who are doing or are attempting to do what we're doing. The difference is in a dense urban area, you've got a lot of potential interference, more and more all the time as the cable companies hang Wi-Fi access points on the poles up and down the streets, and everybody and their brother has a dual band router, so the 5 gigahertz spectrum is very full. But that's not necessarily a problem. In rural areas, you're worried about what is the signal to noise ratio if you're 15 miles away from the water tower where the access point is. How do you get a signal there? And the answer is you use a highly directional antenna that's focused and allows you to receive a signal despite being 15 miles away. Well, it's interesting in an urban area, if you're willing to use directional antennas, now you're fighting not signal to noise, you're fighting signal to interference. But if I have an antenna with a 10-degree beam that's looking at another antenna with a 10-degree beam, first thing off is I'm not receiving interference from 360 degrees in any 350 degrees, in other words, from most of the rest of the neighborhood. And when I do see interference, my 2 directional antennas are pointed at each other, and if there's some omnidirectional dual band router in a upstairs apartment of a building I'm passing over, it's relatively diffuse and low level of interference. So with directional antennas, I can make of point-to-point wireless connections between different buildings.
Rob,
in fact, we now have.
Dive in very quickly, Brough, and ask you what bands are you actually using? You mentioned 5 gig, the 5 gigahertz unlicensed band. Is that all you're using?
No. 5 gigahertz unlicensed, but we're also using 24 gigahertz, which there is 200 megahertz of spectrum from 24.0 to 24.2, which is unlicensed or license exempt spectrum in the US. So we're using, we have radios that use 2 100 megahertz channels, one way and one the other way, so we get frequency division duplexing, full duplex, and we can get 800 megabits each way over those radios. Then we also have some radios that are operating at 60 gigahertz. Those are fairly short range, like 500 meters to at most 1 kilometer. And we have a final kind of radio. These are all unlicensed. And then the final kind is radios operating in the 70 to 80 gigahertz range. These are so-called light licensed at those very high wavelength, or very high frequencies. It's very short wavelength. With even a small antenna, the beam is very, very directional. So you get a license from the FCC for doing anything for a few $100s for 10 years. And then you have to register the endpoints of each link. And you can't put a link that exactly duplicates somebody else. But these things are so directional that we've never run into any conflicts with anyone else in the city of Boston because they're so directional. So were I to try and, so basically we have 4 different kinds of radios we've qualified now from 3 different vendors. And we use them at a bunch of different price points. The 5 gigahertz stuff is the least expensive. The 60 gigahertz stuff is the second least expensive because it's also, 5 gigahertz is leveraging mass market Wi-Fi silicon with custom MAC layer and higher level protocols. The 60 gigahertz, it turns out because of 802.11ad, there are Wi-Fi standards for 60 gigahertz, and there are now 2 silicon vendors who are manufacturing Wi-Fi silicon at 60 gigahertz. And as a result, there are now 2 radio vendors building things into our market who have taken this mass market stuff and launched products and started deploying a couple of months ago. The 24 gigahertz stuff is expensive. It costs us about $3,000 per link, $1,500 per radio, but we get a solid backbone out of that. And the 70 and 80 gigahertz stuff, but we can get 2 gigabit per second full duplex we've deployed, and we can get 5 to 10 gigabit per second full duplex if we wanted it. So there's no capacity constraints, and in terms of propagation and weather, people say, oh, what happens when it rains? So the answer about rain is the atmosphere is basically transparent up to about 10 gigahertz. So the 5 gigahertz stuff has no weather impacts at all. Above 10 gigahertz, you begin to get water vapor absorption, and it increases as you go up in frequency. So our 24 gigahertz links, the longest link I have is 3 kilometers. There's a couple of links, two links that are 3 kilometers. They go across Boston Harbor. And I may be able to shorten them to 2.5 gigahertz, but those are the only out of more than 115 24 gigahertz links we have deployed now. They're the only 2 that are over 2 kilometers are these 2 that go across the harbor. They're 3 kilometers, and in a heavy downpour, they will modulate down from full speed from 700 megabits per second to maybe 200 megabits per second. So 3 kilometers or less is doable. 2 kilometers or less is completely reliable at 24 gigahertz.
Okay, that is very valuable information to know, because there are very few people actually doing this out there today. I think you're blazing the trail for everybody, Brough.
Yeah, and we have a lot of very specific experience with, so 24 gigahertz link, if you're willing to pay $3,000, you can go, 10 miles in the desert. You can go 2 kilometers in Northeast US ITU rain zone K.
Yeah, and then in UK, you'll probably do about 300 yards,
No, you're actually...
yeah, in Scotland, forget it, Corrado, you're knackered.
No, we're doing, we have dual link, point to point to point, to serve a rural location that is completely off grid of everything. And we have 2 links that are about 2 miles each, so about 3 kilometers on the 5 gigahertz.
On 5
At-
gigs.
Yeah.
At what frequency?
Sorry?
5 gigs.
5 gigahertz, yes.
At what frequency? Oh, yeah. Well, at 5 gigahertz, you can go 20 miles. You know, the atmosphere is transparent at 5 gigahertz,
Absolutely.
so there's no weather implication.
That's
for
why
5
we use that
gigahertz.
frequencies.
Yeah.
Yeah, just out of interest, are you
well-
using any kind of, what are you using for antennas? Can you use any kind of active beamforming technology in there?
We certainly could, and that's a whole separate thing which I could talk about independent of netBlazr's primary business. I have a consumer deployable radio that doesn't have to be aimed because it does active beamforming. And I've actually managed to get the U.S. National Science Foundation to give me a series of grants, which are now a little shy of $1 million that I've frittered away over the last 5 years. Government, and we have some prototypes of something that kind of works.
And just on cue, I just happen to have one here. This is the thing called a YB, manufactured here in UK, which has got multiple antennas. They're phased, and you can get about 10-15 dB forward gain from this. But more importantly, it reduces noise, and that comes in a little weatherproof enclosure. And you just whack that up, or on top of a vehicle, and it can operate mobile, which is great.
Yeah, that's it gives you antenna gain, and in some environments that might be useful for signal to noise, but in most places what you're worried about is signal to interference, and that antenna gain directly gives you gain over the interference.
Yeah, the ability to notch out the noise is hugely useful.
Yep.
Yeah. I know of a vendor that has developed a ring that you put around the dish that is enclosing the dish, so it's beamforming, it's directing the beam even more directionally than just the single dome at the back.
So it's a super focused dish.
Yes.
That's augmenting the dish to reduce susceptibility to interference to side lobes.
Siding. Yeah.
In fact, one of our radio vendors is Ubiquity. It's a fairly large company now, and Ubiquity is actually a bunch of aftermarket products showed up to do these sorts of things with the Ubiquity radios, and Ubiquity is gradually getting to the point of introducing these technologies directly into their product line.
Yeah.
Slowly.
We love those guys.
Yeah.
Lots of that product around here have tremendous experience with it and the company.
Well, come on, name some names. What's really good and hot, Brough?
Yeah.
Because that's what everybody really wants. Go on. Don't be shy.
Well, the 24 gigahertz radios are Ubiquity air fibers.
Right.
Yep.
Good old
fiber 24. They're not cheap, but they are. They're actually built by a development team acquired from Motorola before Cambian bought out the Motorola assets, and that team has produced a much more professional radio, if you will, but it's not based on Wi-Fi silicon, and therefore it's more expensive. So we're using Ubiquity 5 gigahertz stuff all over the place. We're using Ubiquity's Air Fiber 24s. The 60 gigahertz radios are from IgniteNet, an Israeli startup. They're called IgniteNet MetroLink. They come with 2 different sizes of antenna. The smaller antenna, which is about 19 centimeters, allows you to establish a link that's up to perhaps 500 meters. And the larger antenna, which is 35 centimeters, allows you to establish a link supposedly up to 1 kilometer. My longest link right now is about 700 meters, and I don't have a lot of experience. We have maybe 3 or 4 months experience. And it was a rocky start. The first 5 radios I bought, that is 2 links and a spare, had all sorts of problems. This would be a year ago, and they were only finally fixed after IgniteNet did a complete hardware ECO. We returned everything, and they basically gave us new equipment. But since that happened 4 or 5 months ago, everything has been working very well. So they definitely had startup problems. We have 3 links deployed and 2 more going in this week. So we won't have a base of experience for another 6 months or so. And then in terms of the 70 and 80 gigahertz product, actually about 5 vendors in that field. The 2 that I have some familiarity with are Siklu, an Israeli company, and Bridgewave. I'm not sure where they're based, US, I think. And we're currently deploying Siklu 2 gigabit radios on a couple of links where we need the extra capacity. And again, I don't have a lot of experience there, but we're scrambling. As I say, our backbone right now is principally AirFiber 24 point-to-point links. And the way we set this up, the network there are 7 places where we're buying upstream connectivity from one of 3 fiber providers. And then there are hundreds of buildings that are interconnected. We have a dense mesh of point-to-point links, and every building that we deploy service in, we try and get a site license that allows us to put 3 or more radios on the roof. So we have a router and 3 links going in different directions. So there's at least 2 paths to every building. So if a building goes out, not everybody is connected directly to fiber. In fact, most of the network is 1, 2, or 3 hops away from fiber. But everybody has at least 2 paths back to fiber, and there's crossover paths so that if a fiber goes out, we can move a network onto a different fiber connection with BGP handles that.
So you've effectively created a mesh using point-to-point links instead of creating a point-to-multipoint.
A lot of people use, I'm using mesh in the mathematician topological sense, not in the common, not a mesh network. We don't have any omnidirectional antennas anywhere, and everything is operating on different frequencies. And it's clearly, we're trying to have a dense topological mesh of point-to-point Ethernet connections between routers in every building.
Yeah, that's a good lead on to the question. How do you present the service to the end user?
Typically as an RJ45 jack, where you make a gigabit Ethernet connection, and we provide whatever we can provide, which depends on the building. In the vast majority of buildings, we're offering 300 megabits down, 300 megabits up for $59 a month.
Well, I'd sign up immediately, Brough. You know that.
No contracts, no funny escalation. No strings, no funny business.
No strings, no wires even.
Every month and so forth. A lot of we also have a 500 meg service, and we're going to be testing out a gigabit symmetric service in the next 3 months. Capacity radios and so forth. Basically, there are some, once we get to a building, if it's a multi-tenant building, say an apartment building or a condo or a commercial building with multiple businesses, or one business that's willing to pay a lot of money, then we put the 3 or more radios on the roof. We run, they're all power over Ethernet. We have typically MikroTik router and a Nutanix PoE switch located somewhere in a telco closet on the upper floors, or in a mechanical room somewhere near the roof that's powering the radios. And then we wire vertically down through the building with Cat6 Ethernet cable, and we put switches and deliver service in a kind of conventional fashion to people over whatever wiring is in the building. And that's, now if the building has been built or remodeled subsequent to 2002, it's highly likely that it has Category 5 wiring, and we can get a gigabit connection to the subscriber's room and deliver whatever we can deliver. It was built in the 90s through 2001 or 2002. It probably has Category 3 wiring into the from the telco closets into the individual apartments. Category 3 wiring was rated for 10 megabits, but if you've got short, that's over 100 meters, 330 feet. If you've got short runs, you can reliably do 100 megabit Ethernet over Cat3. Yep. And sometimes you can do a gigabit over Cat3 if it's 50 feet or less.
If it's well twisted.
Well, Cat3 is what it is. I mean, its twisting was designed for 10 megabit Ethernet over 100 meters. It was not designed for whatever, but in fact, for short distances, it does work. So we can pretty reliably, in apartment buildings and condos that were built or remodeled in the 90s, we can offer 100 megabit symmetric service and do that over the existing building wiring. And we just tell either the apartment manager or the condo board, we can do, if you want to upgrade your wiring, we can give you, 500, 500, but meanwhile, we're offering a 100, 100. And we've actually had individual condo owners Cat 6 wiring put in from their apartments to the central telco closet. So there are buildings where different people have different grades of service due to, that's a condo. In an apartment building, obviously, it's the apartment owner has to decide whether they're going to do that or not. And finally, we don't do this often. We can run over legacy telephone wire using VDSL 2 Plus, Profile 30A, and that will allow us to get 100 megabits symmetric over phone wire for realistic distances within the building. So we put a D-SLAM in the basement, and we jumper things to people's telephone connections, and we put a little box. It costs us $103 each in the subscriber unit. So there's basically, I mentally think of this as $200 of extra cost for the installation. We don't seek out buildings which don't have modern wiring, but when the occasion arises, or for example, in one case, it's a 22-story apartment building in a location where we could get fiber, and it was a beautiful retransmission site. And so we said, sure, we'll do 100 meg and whatever extra
to the roof
capital if we can put 12 radios on your roof. And they said, fine. So we have a fiber head end, which has only DSL speeds inside the building. So
great.
How about when it comes to brownstones? Because some of your marketing indicates that you go down to individual family residences, and how are you able to deal with them?
Okay, well that we don't do 100 megabit stuff. We offer 50 megabits, and originally back in 2012 we were pushing 15 megabits, and we do that basically anybody who is within 1,000 meters, or I say 800, but our sales department seems to say 1,000 of a building, the rights to put extra aerials up. What we do is use things that are designed to be relatively high gain point-to-point radios, but with we basically take a 30-degree beam and we create the equivalent of a point-to-multi-point sector that's only 30 degrees wide, and we use DFS frequencies at 5 gigahertz in 20 megahertz bandwidth chunks, using ubiquity, either M series or more recently the AC series, and we can get 50 megabits to people. We're typically relatively few people per sector. The max is 15, and it depends on what the actual utilization of people are. The statistics are not as good when you're concentrating 15 thing as when if you can concentrate 100 people onto some upstream, if you have enough capacity to do that, the statistics of any one person out of the 100 all averages out. When I have an apartment building with 120 units, if we give them all 300 meg service, I know that on average, during the residential peak time, say 9 p.m. till midnight, I'll see 120 or 125 megabits coming out of those 100 users, or I'll see 1.2 or 1.3 megabits per user, because some people are watching Netflix, and even in HD that's only a few megabits per second. Some people are browsing the web, but they hit, they get the advantage of 300 or 500 megabit service is not that you need it all the time, it's that it gives you low latency when you want to browse the web.
Mm-hmm.
Yeah. But he's browsing the web, bang, they get the page hits real fast because they got a 500 megabit downlink. But if I look at their average over an hour, they're running 1 or 2 megabits per second. And then of course some people are out to dinner. So if I can aggregate 100 or 200 people with 300 megabit service, I know that all I need to do to guarantee that anybody who runs a speed test will see 300 megabits, for example, is I need 300 megabits of headroom, whatever is the peak of the actual usage during the busy hour or the busy 3 hours, 9 till midnight. So a building with 200 people in it, if I'm seeing 250 megabits of traffic in 1 minute averages from 9 p.m. till midnight, have 550 megabits of capacity at that building, anybody who does a speed test will see 300 megabits. So the statistics work really well for 200 users. When you've got 15 users on an access point, 15 is subject to a lot more statistical variation.
Yeah. Brough, sorry to interrupt you, but I've just had, well, a couple of days ago, I had an update from Ubiquiti about a new release of the AirOS software, the AirOS firmware, with the GPS sync feature.
Yeah.
That helps a lot against latency problems, and that people that install that have reported exceptional performances.
So how does that work?
The main,
how does that work?
Well, the main thing that GPS sync gives you is when you have multiple radios on one rooftop, and they're using time division duplex, that is, they're transmitting part of the time and they're receiving part of the time, you would like all of those radios to be transmitting at the same time and receiving at the same time, because even if you've got a spectacular antenna with a 50 dB front to back ratio or a 60 dB front to back ratio, if you are transmitting at dBm and receiving at -70, that's a 90 dBm ratio, a 90 dB ratio, and your front to back rate is only 50, transmitting is going to be blowing up the other guys nearby if they're on the same frequency. If they're on nearby frequencies, you've got some filter advantage, but even there, it's very easy to overpower that are within 10 or 15 feet. So the great advantage of GPS, were it to actually work, and Ubiquiti has been promoting this, and so I'll believe it when I actually have units running, put a bunch of units on the same rooftop, on the same channel, 30 degrees apart, bing, 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 and actually use them. But I don't have experience with it actually working yet, so I'm hopeful.
No, yeah.
Okay, next little question is, now you've built this marvelous hybrid network, how do you manage it?
Okay, well, that's a work in progress. We started out years ago with a mixture of a microtics program called the Dude, Smoke Ping, which is an open source, very good predict. I'll describe them in a moment.
So this has been said that this is the Latvian The Dude as opposed to the Dude
right.
from the Asterisk community.
Right, yes. But we have abandoned that now. What we are using now, as of a year ago, and it's working extremely well, is something called netXMS. Basically, we're running netXMS. We have maps of our entire network, probably 90 separate submaps that are indexed and connected and so forth, to cover the thousands of devices we have out there. netXMS does polls of every single device once a minute and accumulates many tens and hundreds of gigabytes of data, in the last year.
Yes.
Basically,
and it's open source too, as Andy quite rightly points out.
Yes, it is. It's open source, and there is support for it. We're not currently paying for any support. We're just using it. And we have integrated that. It has a much more robust than microtics, the Dude, scanner, which when we deploy new devices, they get located within 2 hours. And then somebody just has to drag to a map and indicate and correct, if the, a couple of minor fiddles, and it's part of the network, and it's being monitored. And we're accumulating SNMP data. We have standard templates for each of the devices. I'm still amending the template for the IgniteNet radios, and I'm just starting on the template for the Ciclu radios. But basically, there's a template, and when it discovers a new thing, it tests the SNMP against the template, and if it matches, it picks the right template.
Okay. And
applies that and starts collecting data.
I'm guessing that you're contributing your templates back to the open source community.
We have, in one case, most of this, we haven't done anything really unique in most cases. But yes, in principle, yes, and in practice to
because I'm just thinking how useful all that stuff would be to lots of people like Corrado.
Yes.
Yeah. So then the other thing, so netXMS is our discovery tool, our SNMP monitoring tool, our mapping tool. It's kind of the central thing. And then as I said, we have 7 different fiber feed points. Those 7 head ends, I have a ping server, and we're running an open source program called Smoke Ping. It's a burst of 10 pings every 1 minute to every device, obviously sequenced out so as to distribute the load on the ping server. This is a beautiful graph of the mean of, or I don't know if it's a mean or the median, but basically a midpoint mean bar and gray smoke above and below on this graphical representation, representing the longest and the shortest. Wonderful leading indicator of interference or other problems, because radio is subject to interference. It starts to do retransmissions at the radio frame layer, which is below the MAC layer, below the IP layer, and not seen by most of the normal data networking tools.
Yeah.
By smoke ping as additional smoke, because the ping variation changes. So smoke ping is an invaluable tool, is a distributed smoke ping network with seven separate ping servers, 1 at each head end. I have tunnels between head ends and a pile of other kludges which go through the public internet, and I don't want those latencies confusing me over what's work. From netXMS, you can right-click on any device, and you get a bunch of choices, and one of the choices is to access the device, and I've just augmented those menus to include a direct hook to retrieve the smoke ping graph for that device. which hooks you into the smoke ping server in the right place for the right thing. So my distributed smoke ping network is available centrally from the NetXMS monitoring program.
So typically, what do you do? Ooh, nasty noise. What do you do if your links do get a bit smoky?
Well, I'd like to tell you that I have automatic alerting. I don't yet. But basically, if we're getting smoke, then it very much depends on what the link is, and somebody needs to go and diagnose things. Gigahertz, point to multi-point, then it's probably interference. If it's a 5 gigahertz point-to-point link, it's interference. It may be something else. If it's a 24 gigahertz link, then I go back and I look at signal levels and I look at other things. It doesn't happen often, but I had one last week, and it turned out that this installation crew did an installation without a plan that had been reviewed or approved by anybody, and they slapped up a new air fiber radio on a roof that already had an air fiber radio. So they were both transmitting on 24.1 and receiving on 24.2, so that's cool. Are unfortunately less than 10 degrees apart, so the other end, you know, completely invalid something or other, and now they've installed a business customer who's moved in and is pulling 100 megs more or less continuously during the day, and screwing up the condo that with 35 or 40 in a 120 person building. You know, that's just a QC screw up on our part that
smoky links
should never have.
Yeah.
Right. So the answer there is the new link is extremely short, way down, so that we've dramatically reduced the interference on the condo that was the established condo that should never have been interfered with. And we're going to replace that link with a different technology that's not operating because, you know, we don't have a different path and so forth. So could be all sorts of things. This one was we shot ourselves in the foot, and we need to re-engineer the second installation so it doesn't interfere with the first one.
Right. Anyway, Jay Carpenter, who just popped up there, the postage stamp of Jay there, has got a penetrating question apparently. So go ahead, Jay.
Actually, two. Thank you, James. So I have two questions. One is, have you? And I think your project is really, really cool. I love the idea and the intention of it. And have you looked at optical links at all?
Yes, I've looked at optical links, and I have also mentored to a limited extent an interesting guy in Slovenia who is building a 100-meter extremely low cost. It's supposed to be 100 euros. I think it's about 300 euros right now.
Yeah, we actually had him on the VUC about a year ago.
Okay, good. Yeah, I'm very interested. There's been nothing that's been affordable and directly relevant. The vast majority of our links are under 2 kilometers. A significant percentage are under 1 kilometer. And a small number, 10% or something are under 100 meters. Not a lot of really short things. So it comes down to, I'd love to have a 10 gig optical link, but I'm not going to pay $15,000 for it. If I can put in something that costs me, it gives me the 2 gigs or the 4 gigs that I need for $7,000, or can give me something just under 1 gig for $3,000. So I'd love to see an optical device that made sense, and I keep looking. Do you have any ideas?
Well, I guess I was looking for a comparison and contrast between your radio architecture and the optical architecture. It sounds like you're looking at both. Is it basically just distance and cost that are the considerations now?
Yeah, it's absolutely, it's cost and performance. All I'm looking for is to use wireless ways of providing an Ethernet connection between two routers. I have a router at every building, and I want to put Ethernet connection to a bunch of other buildings, and I get that Ethernet by having a radio bridge. And if it's an optical bridge, that's cool. It's purely a matter of cost and performance and reliability, as we learned with the first generation of Ignite radios. So I would drop in an optical link that made sense in a heartbeat, or in a month or two while I tried it out and got everything working.
Yeah,
excellent. Thank you.
The name of the outfit we had on was Koruza, K-O-R-U-Z-A, VUC619 on November the 11th, 2016. So not that long ago.
Right, right. And that's an extremely interesting thing. I don't have that many links that are 100 meters. So I don't have a lot of need for that product.
Yeah, but they're claiming links of up to 10 gigabit per second, up to about 150 meters. So building to building, perhaps. But
yeah. That's what I'm interested in, and I met Luca in Berlin in 2012, or at one of the Battle Mesh or some event maybe 5 years ago, when he was I think still an undergraduate or maybe a grad student in London, and I've been sort of giving him email support and introductions wherever I can. I haven't actually talked to him in about a year, but I was trying to be very, very encouraging because it sounded like something I could use. So we haven't.
So you just mentioned something that I think is very interesting. Did you attend Battle Mesh that just happened, what, a month ago or so?
No, I haven't. See, separately, I alluded to earlier this project that's for which I've gotten various National Science Foundation grants. That's to develop something which would be used in limited mesh networks installed by non-professionals, by consumers, if you will. And I've attended several different Euro mesh networking events in 2010 and 2012 and so forth, when I was working on the early versions of that, both to talk to people and get connected to the community. So I follow these things remotely at this point, but because netBlazr, the service business, has been growing so rapidly that I'm barely scrambling to keep up with the infrastructure and the monitoring tools, the NSF-funded development project hasn't turned into the business I'd like to turn it into. The idea there is to develop something that a consumer could hang in their window, which would be actively steered, automatically steered, so it wouldn't require any aiming, it wouldn't require access to the roof, it could be installed with no truck roll, and it worked at available frequencies, which were only 5 gigahertz when we started in 2011. If you put a large steerable antenna in a window at 5 gigahertz, it's going to be quite substantial, like 30, 40, 50 centimeters wide. So the other criteria was it needed to be transparent. And that's what I got the National Science Foundation to fund. We have actually managed to build a very interesting transparent antenna technology that behaves within 2.5 dB of a pure copper antenna in terms of performance, but turning this into the antenna piece of a larger project has been slow going because I haven't been paying much attention to it.
When you say transparent, is it actually transparent, or is it sort of a mesh construct? Or
the material we're using is actually clear plastic with 20 micron wide silver lines in a 300 micron square grid. So unless you get a magnifying glass, you can't see this. When you get up really close with a magnifying glass, you can see that it is 20 micron silver lines in a square mesh, providing the conductive material. Now, there's a bunch of issues associated with using this stuff to actually propagate signals and which way, how it works, and but its RF performance is different than what you would think in terms of its DC performance. But of all the various things we tried, way better than indium tin oxide and so forth. As I say, we've got demonstrable antenna arrays with limited beam steering working, and the antennas, they're multiple patch antennas fed by transparent transmission lines. The system is about 2 to 2.5 dB less efficient than if we'd made it out of copper on a good dielectric. This is this funny material on Lexan, and some of the compromises are. Excuse me.
Yeah, that's just fantastic. I could see that if available would be widespread.
Well, there's a long way to go from a research demonstration funded by the National Science Foundation to a product. For example, Lexan is not a controlled material, so I made a project. I bought a vast amount of Lexan from one batch so that I would know that the dielectric constant would be the same over the next 3 years. That's not a manufacturable product. So there's a whole set of issues to get from a research thing to an engineering prototype to a production prototype to a product that's actually maintainable in the field. And right now we have $1 million of federal money, well, $920,000 of federal money and 80,000 or 100 of our own, plus countless hours of our own time. But we have other technology. We don't have a product, and it has been on the back burner compared to the main business. But the motivation is still there. Do local neighborhood installations. It's one thing to do buildings with 50 or 100 or 200 doors. It's another thing to do brownstones or assorted buildings that have only one or two or three residences per building. Each one of these requires a truck roll, and today it requires an antenna on the roof, which is subject to weather and means you have to get landlord approval if you're renting. The idea of being able to hang something in the window, connect together 6, 8, or 10 people in a neighborhood, and only have 2 truck rolls to provide 2 different feeds to this cluster of 6 or 8 people, that dramatically cuts down the cost of doing something. And you can think about same sort of thing that Google thought of. I actually was promoting 5 years ago, 8 years ago. You have promotions where if 6 or 8 people on your block or within view of each other are willing to sign up as a group, bring service to your neighborhood. All you have to do is X, Y, and Z. So it's a very interesting concept. I don't currently have the budget to turn this into a product or the time to go and raise the VC funds to do it, or in fact the team that I could sell to VCs. But it's in the back burner, and I was thinking of what's my next step. I need to resolve that before the year is out.
Okay.
Brough, James, forgive me, but
go.
Just a quick, no, Brough, and I had some technical difficulties earlier, so if this was covered, I apologize for bringing it up now at this late date. But I know that the United States is a very peculiar and particular atmosphere to do these kinds of things, and I was curious to know whether you would like to. This is a sensitive issue, but whether we'd like to speak to any legal or community challenges that you're faced with. because it seems that it's in a sense one's hands are tied for this kind of thing of providing internet. So if you have anything to say on that level, we'd love to hear about that.
Well, we're in the U.S., so we're in better straits than a lot of countries.
Well, compared to, say, I happen to be in France, but a lot of the people are in UK. In Europe, there's a I'm trying to think of the right word, but the point is there's a lot of competitive, in other words, the people who have the monopoly on the infrastructure for the internet are obliged legally to share it. Whereas I know in the US, for example, in New York City, we've heard that people who have tried to set up internet in their building for reasonable costs, high speed, have had challenges. So I just was trying to get you to speak on that and whether there's a problem in Boston, whether you, but understanding that you not necessarily are able to comment.
Yeah, no. I'll comment on anything. Hell. Certainly Boston has Verizon phone wire, and an enormous number of those buildings have Verizon fiber, even though Verizon does not offer their so-called FiOS service in the city of Boston or Cambridge. But there are a limited number of buildings. So there are, hundreds of thousands of buildings that have connections from Verizon. There are 90% of them, all the residential ones and many of the commercial ones have connections from Comcast. There are a couple hundred buildings that have fiber connections from other carriers like Level 3 or Light Tower or Zayo or, competing companies. These are typically only that have had cell sites in them or buildings that are business towers, but there are a few hundred locations in the greater Boston area where there is competitive fiber available, and my three upstream providers, one of them is Light Tower, one of them is RCN Business, and one of them is a company called ExcelX. None of these guys are at places where I can get access and run radios. And so I'm not dealing with British Telecom. I'm not dealing with OpenReach. I'm not dealing, I'm basically buying internet transit at some building, a data center. By the way, I'm not paying for rental at a data center or paying cross-connect fees or anything else. I'm buying internet transit stations in greater Boston and talking BGP upstream over that thing. So that happens to be the best deal, and that's repeatable in most of the top 50 cities in the US, including New York. So there are selected locations in New York where I could get fiber from a variety of people, including Light Tower and Level 3 and so forth. A deal that's compelling to the building owner where I can get roof rights without having to pay rent, then I've got a jumping off point for a wireless network, and that's what we're doing.
Okay, my question is really based on whether there was impediments put in your way by some local or whatever governments, because I've heard that it's not that easy. Whereas, just to repeat, in this country, what's happened is that we, the taxpayers, have pretty much paid for the infrastructure, but then there was one company who had the monopoly, and as a result, they were forced to share, both in the sense of cable and 4G, by the way, LTE. They were forced to be able to allow people to resell. And I think that's the key to the fact of why we pay, in this country, we're paying less than $20 for an incredibly good internet connection.
Yep.
Whereas in the United States, if you go to some part of Oklahoma or Texas, or particularly in the middle of the country, Minnesota, whatever, it just seems like the lack of competition has made it very difficult. And so that was the basis of my question.
Yeah. No, there's absolutely the case. The reason the U.S. service sucks is that we have monopolies. Used to be the phone company, and at this point, viably, it's really only the cable company because the phone wire is really, really obsolete.
Right.
There's a cable monopoly, and the U.S. has not forced any kind of either structural separation or even operational separation. So none of that is available to me, so I am working around that. That was one of the things that I was extremely pissed about that caused me to start. You know, but my thought was to do a wireless-based end run around the monopoly, and that is possible. We're doing, but it does mean one advantage is we don't have any competition, because what's the competition? It's Comcast. And at the ratings on social networks, on Google, on Yelp or whatever, netBlazr has a 5-star rating. Verizon has 1.5 stars, and Comcast has 1 star because you can't rate lower than 1 star.
And that's excellent, bro. So I'm sorry, go ahead. I was just...
Yeah, so it's not hard to compete in the U.S. because there is, you know, and it's still a terrible thing. And my regret is that I don't have millions of subscribers doing as yet. That's the long-term vision, is to find a way to do millions of things and just bypass the broken U.S. public policy.
Right. Okay. Corrado has a, oh yeah, that's readable now. Corrado, can you comment this for us? Because it was for Brough to show him.
One of your links.
It's your link, so I'm showing.
Yes, exactly. It's one of the links we have in the 2-leg link that we use to broadcast a simple fiber to the cabinet connection from one urban location to a rural location. It's not even optimized, but it's the capacity is about 200 megabits per second. You can see that, and the distance is about 1.5 miles, as you can see from here. And they've been running for forever. 1 terabyte of traffic going through, as you can see. Reliability 100%, never gone down. I'm touching wood right now while I speak, but we are entirely happy with these devices, and they saved the bacon of that business.
That's an extremely familiar picture because we have a bunch of that stuff too. So yes, absolutely.
And, Corrado, can I just quickly ask you just to scroll up a bit so we can see that matrix at the bottom, and that's showing the 64-way QAM, the scatter diagrams, and that looks pretty clean because you can see there are little groups of shot falling within the grid, which means
what are these amoeba that we're seeing?
That's what I'm trying to explain badly. So this is a 64-way QAM, quadra amplitude modulation.
It's up here, 64 QAM 2x2.
Yeah, and
reception. Every single square is a group of bits and bytes that is being sent at the same time.
And when it's nice and clean, you end up with these groups of, they look like shotgun shot, falling in the middle of your grid square. But if it gets noisy, then that grouping of shot spreads out, and it just, then the whole thing struggles to determine what signal and what's noise. But anyway, that's a good example, an illustration of 64-way QAM in operation live, and I think it's brilliant. And the cost of these things is not vast, is it? It's just a couple of £100.
Can I point you out to another thing that I'm highlighting now?
Oh yeah, the average latency 0 milliseconds.
That is where? How?
How? Well, I don't understand
even
how that can be, because as Scotty used to say, you can't beat the laws of physics, and you're going to have a little bit of latency somewhere.
Yeah, it's the speed of light.
The latency. I mean, besides the speed of light, there's also packetization, frame delay and whatever, serialization delay and so forth. But
That is the latency between the two devices.
Right, right. So my thinking is if I've got less than 100 megabit connection, I'm going to have a millisecond latency per hop. And if I've got less than a gigabit, 700, 800, whatever, I'll have 300 microseconds per hop. And those are just rules of thumb. But the point is, the extra latency of somebody being 4 or 5 hops away, 3 milliseconds grand total, it's not material compared to everything else. So latency isn't an issue in this network.
Yeah, interestingly enough, there's it's a growing business in radio-based links now, because propagation with a radio wave is the latency is lower than propagation through a fiber.
Yes.
And so if you've got a city dealing system and you can shave off the odd millisecond here or there, that means millions of dollars. Anyway, that's a good lead in, because I know Jay's got another question about satellites, and I think we're probably going to see it off with by saying crap latency. But go ahead, Jay.
Yeah, that's kind of what I was guessing, since we're talking about latency and we're talking about, let's say, alternative networking topographies. But I was wondering, what's your opinion on satellite linking? And yeah, but do you see any improvements in there? And there, there are some experiments with high altitude drones that are going on. Have you looked at that at all?
I've just followed, the various announcements of yet another satellite system and so forth. Certainly a low Earth orbit satellite, or drones at 60 or 70,000 feet, or blimps or something, possibility. And certainly a geostationary orbit satellite is hopeless. That introduces a quarter second of delay. And you excuse me for moving, but my computer battery is running low, so I've just moved to a slightly noisy area. I'm very interested in Google's balloons.
What about Facebook's Project Aquila, which is actually designed and built about 30 miles away from where I'm sitting at the moment? British technology.
All right, all right.
You don't know about that one, do you?
I've looked at.
Basically, in summary, it's a solar-powered aircraft which flies at around 55,000 feet, so above the air traffic, with a mission life of about 4 years. So you put it up, just go round and round in circles.
Yeah. So that's entirely viable if they can get the economics to work. The distance. It's not. That's going to introduce some latency. 50,000 feet round trip is 100,000 feet, but the speed of light is pretty damn fast. So
yeah, but compared with a geostationary orbit, which is what, 176,000 kilometers or whatever out, it's tiny.
Yeah, it's a nanosecond per foot, and so what's the 100,000? 100,000 nanoseconds. So it's a millisecond.
And if I had to choose between Google Balloons, Project Loon, or a Facebook solar-powered drone with a life of 4 years, I would go with a solar-powered drone every time, even in UK.
I feel the need to chime in here, sorry, to tell you that Orange here in France has been deploying fiber all over our city, and you cannot do 20 steps outside without seeing a truck. And so they came to this building. Now, I have VDSL, so we're moving soon. We're not jumping on their offer for fiber. But our neighbor right next door ordered Orange fiber, so they came and wired the fiber into the building and wired it to their apartment. But unfortunately, there's no network connected to it. So while they connected the fiber outside in the whatever that is on the street, there's nothing there. And they still haven't connected. That was a couple of weeks ago. There's still nothing connected to it. So it's ironic, we're talking about satellite this and latency, blah, 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 fiber. This is fiber to the home. Fiber, I talked to the guy, fiber is coming right to their router, whatever that device is that accepts the fiber. But there's nothing on the street connecting it to the network. So they have no connectivity. Fortunately, they have their DSL, obviously. But my point is, well, I don't know what my point is, except
Yeah,
that
well, yeah, that's a bit rambly, wasn't it? But you made it. Yeah,
I think you got it.
yeah.
That
Orange France have got some project managers that need sacking.
they do, and I
their
want to go
sequencing
into what
wrong.
happened when we first moved in. But my real point is, it doesn't matter what whatever that layer of ISO is that does that, but you're either providing a service or you're not. And Brough, you folks are obviously doing that. And who cares whether it's radio, fiber to the cabinet, fiber to the home? I don't know what it's to, but go ahead. I just think that's funny. But you guys are doing it.
Yeah.
At the end of the day, there's no substitute for having people who actually understand what they're doing and execute with a certain amount of passion. And I think that's what your team are all about, Brough. You believe in what you're doing, and you just go and do it, make it work, because you can and you care. And that's why you're a hero.
Yes. Yeah. Okay. Well, thank you. All we have to do now is blow this out to millions of people instead of thousands.
And how do we do that?
That is the question. How do we spread this to other metro areas? Does it take some sort of national cooperative, or because you clearly have the seed of something, and now we need to get it in, Houston, Dallas, wherever. Yeah.
Well, there are other companies doing things somewhat like we're doing, including a company called WebPass that started in San Francisco. Google recently bought WebPass. Yeah, we shall see.
That's a good sign.
There are about 5 such companies that I'm aware of. I don't know that anyone else has costs quite as low as we have, but the point is, the public policy in the U.S. is so screwed up that I'm only impressed that there aren't hundreds of companies doing what we're doing. So we're certainly thinking in terms of getting this to be something that could be cloned in other cities, and if we could get this the infrastructure to that state and clone it in 1 or 2 other places, then I'd be up for raising a potload of money and trying to go after 50 metro areas or something like that. But that's not in the next 12 months.
Well, something that would help would be some better spectrum, because at the moment you're using license-free, 5 gigs and above.
No.
So, what you could say no.
No, I wouldn't say that right off, because the other thing we're looking for is low cost of equipment.
Absolutely, and that I was just getting. That's going to be my lead-in for CBRS, the license shared access spectrum at 3.5 gig, which will be very, very low cost as the mass production for CBRS type equipment kicks off. Still early days yet, but it's going to be very, very cheap.
That's certainly a possibility, and I'm certainly open to anything that ends up being commercially viable and low cost and useful. There's the thing that there's a petition before the FCC generated by the folks at Mimosa to get unlicensed access to 10 gigahertz spectrum. There's a bunch of radar bands and other things up there that are mostly not used in most geographic locations, typical of most spectrum.
I think if you're a radio ham, you already have access to the 10 gig band.
You've got
on a secondary non-interference basis.
Yes, to part of it. Yes, there's at least 100 or maybe 200 megahertz of that band that's available to amateur radio people. The point would be to get tertiary access to there's like 800 or 900 megahertz of potential stuff that could be available. I'm extremely attracted to that because it would be pretty damn quick. And 5 gigahertz Wi-Fi silicon, 10 gigahertz, the atmosphere is still mostly transparent. Water vapor just barely beginning to kick in, so you could go 10 or 20 miles if you wanted. It's double the frequency of the stuff that I'm working my transparent antenna with, which means that the wavelength is half as much, and I could get twice as much antenna for any given size. You know, there's a lot of things that would be really attractive, and you could move pretty damn quickly in terms of making a low-cost mass market thing just by upbanding 5 gigahertz silicon. The chances of that happening, of that spectrum becoming available, are pretty small right now.
Well, there are all kinds of crazy things going on at the moment. Like, all of a sudden, there's all this discussion about radio hams doing radio ham LTE, so 4G TDD in the ham bands. Which, you go back 2 years ago, that was totally, you know, fiction. But now it's very real all of a sudden. And things like software-defined radios, things like the Lime Micro SDR boards and all the other bits and pieces, just make it very, very feasible, very possible.
Don't you think that at some point we're going to even get beyond radio completely, though? There's going to be some kind of, if it's not a transponder, mental, I don't know, technologies change, and that's just the support, that level. But it doesn't really matter. What we need is a way to connect.
Yes.
And
well, don't you think it's amazing how far we've come in the last, I don't know, 20 years?
Completely. James, you're here.
And we're running around with things like this in our pocket, which are, you know, 40,
not me.
40 LTE bands with an 8-core processor. It's a supercomputer.
Yeah.
In our pockets with a next, well, I don't know, 500, how many gigs of memory in this, but a huge amount.
But radio could conceivably be replaced by some other kind of energy. Anyway, the point is that doesn't matter. Brough, we need to get you on it at least
every year.
At least once a year.
And then do a reality check.
Reality check, exactly.
Yeah. What is feasible using stuff that's available out there, which is cost effective?
Exactly.
And you know, real stuff, not experimental stuff.
Okay.
And
okay.
Without a doubt, Brough, you operate in the real world, the real engineering.
That's for sure.
Yeah. All right. So you heard it here first. Brough said yes. That means he's going to come back within the next year. Any final questions from anyone before we close this out? I'm going to watch IRC.
I have a technical question.
Sure.
Probably a bit boring, but anyway, did you have any problem with scalability of so getting more customers in, and how do you deal with that, if you ever?
Yeah, everything is about scalability, and we're constantly reworking you know, what we're doing both technically and then business organization, and how does the customer support work. And you know, in some sense, any startup is about you got to come up with a product or a service, but once you got the business plan that's working, it's all about how do you scale it. And yeah, that's what we worry about every day. As I say, we're not in a position to blow this out across the country, because there's a whole set of infrastructure related things that include not only technical resources, but standards and training procedures and how, you know, whatever, before you could pop it up in another city. But those are things you think about, and that's clearly what it takes to go from thousands to millions.
Well, we're looking forward to having you go from thousands to millions, Brough. But in the meantime, keep in touch, and we will prod you from time to time. We're going to ping you and try to keep you in our loop of information. Meanwhile, I want to thank you very much for coming by, and I want to remind people that it's netBlazr. Let me try to spell that. NetBlazr. Thank you. Zed, I said Zed, but it's
Blazr.
Z.
Blazr.
Blazr. All right.
Thank you.
Anyway, you will find that. Thank you very much for filling in, Brough. And I'm going to make sure that it isn't 364 days before you come back. Okay?
Okay. Thank you.
All right. With that, we're going to close out. We're going to, thanks to Jay Carpenter, by the way, thanks to Andy Smith, thanks to Tim Panton, who disappeared as well. Corrado is here, James Bodie's here, and we're going to continue with the mature audiences only segment in just a moment. Here we go.